Hello. Let's get started. First of all, thank you for coming. My name is Marko Martinovic. I'm a backend developer and a team lead at Inchoo. Inchoo is a Magento solution provider from Croatia. If you probably heard about our blog, this is the first thing people noticed when you say Inchoo. And what I prepared for you today is an overview of what awaits us in terms of caching once Magento 2 gets out. So before we start, it would be interesting to see how many of you actually tried Magento 2, tried playing with its code, dependency injection, and things like that. Some hands, please. Okay, that's not a lot. Benchmarks, you have to do a better job. Okay. Our Magento experience taught us that conversion rates are strongly tied to page load times. Okay, Magento 2 is coming out, and this isn't going to change. Therefore, as outlined by Alan Kent, Magento chief architect, on his blog, you have details there. One of the goals for Magento 2 platform is to improve performance and scalability. Caching definitely plays an important role to achieving this goal. So, let's begin with the architecture. Caching in Magento 2 is still built on top of Zend cache component of Zend framework library version 1. If you've been working with Magento Enterprise Edition, you probably noticed these two separately configurable cache instances for storing cache. So you could separately configure cache storage for general cache types and for PageCache. So in Magento 2, we still have these concepts of front-end cache models. We use to access data in cache and backend models, which allows us to store this cache data in a different places. For example, files, database. Don't do that, please. And in the latest Magento versions, we usually use Redis for this. Now, this, you probably noticed, this isn't much different than Magento 1. Okay, in Magento 2 we have this this abstraction level of abstraction to cater to dependency injection and to this loose coupling that's promoted for Magento 2. And one of the examples is that we have dedicated cache type classes, which actually represent these front-end models. And cool thing is that now, when you use specific cache type in Magento 2, it enforces specific cache tag. So, okay, I'm using, I don't know, view files fallback cache type. Whenever I save something into cache storage, my relevant cache tag is automatically added. Great thing if you ask me. Now again, these are the front-end pools. If you use Magento Enterprise Edition, this will probably look familiar because we have, again, two front-end pools which are used to organize cache types. We have the default front-end pool, which is used for holding general type instances. These are cache types, all the other cache types except PageCache. And we have this other front-end pool, PageCache. It currently stores only PageCache type instance. The whole point is actually to be able to independently configure storage location for different kinds of cache. Now, backend adapters, actually we're talking about storing cache data. First thing I noticed was that Zend cache backend file, which was the default backend adapter in Magento 1, has been replaced by CM cache backend file. And CM cache backend file has been contributed by Colin Mollenhauer. You probably heard of him. He's to blame for these backend adapters for Redis in later Magento 1 versions. Now we have this backend of his for storing cache data in files in Magento 2, and this backend claims to improve clearing by cache tag. With Zen cache backend file in Magento 1, this is a very slow operation. When you have to clear cache by cache tag, Magento has to go through all the files because of the way cache is organized inside the files. Now, the other backend adapters, all the usual suspects are still here. Interesting thing, now we have a MongoDB adapter. This means that we can actually store cache data inside the Mongo database. I haven't done any tests, but since we're talking about full-blown NoSQL database with full support for storing tags and solid performance, combination of Magento and Mongo database definitely seems very interesting. Now cache types. These are the cache types you will encounter after you open cache section in Magento 2 admin. Cache types which are relevant for this overview are outlined with bold fonts. So we have collections data cache, EAV types and attributes, view files fallback, view files preprocessing, and last but not least important, PageCache. These other types are either unchanged when compared to Magento 1, or they simply cache XML. That makes them less interesting for this kind of overview. So let's proceed to collections data cache. So the collections data cache exists in Magento 1. It's there implemented as a part of Variant DB collection class. Now in Magento 2, with all this abstraction, we have a fetch strategy interface and the actual loading of data in Magento 2 for collection is delegated to this interface, which then transparently returns results using either query or the cache implementations. This means that we can, by default in Magento 2, collections are configured with query preference. This means that collections in Magento 2 are not cached by default. This is the same like in Magento 1. The only thing is that implementation is different, a bit more abstract. Now, store group, store website collections are cached in both Magento 1 and Magento 2. In Magento 2, we additionally see a catalog category collection cache. It's a great thing. I hope that before Magento 2 gets out, many collections, resource-intensive collections in Magento 2 will be cached, if possible. Now, the EAV types and attributes. This one is actually a funny one. EAV types and attributes cache exists in Magento 1, although nothing has been stored with its cache tag for a couple of years now. So, strangely, in Magento 2 current code, it's alpha. This cache type is still here. It's still not used, and we didn't manage to find out why, actually. If I remember correctly, this cache type was commented out somewhere around Magento 1.3, I believe, and function invocations for triggering this type of cache was removed in something like Magento 1.5. How this happened? One of the developers at Inchoo has an interesting theory. So one developer is working on it for a month, other comments it out for testing, third one is then, of course, afraid to enable it back. Okay, this sounds funny, but no matter how funny it sounds, since we still don't know why this cache type is present, our merchants clear it daily, even though nothing is stored inside. This may actually be pretty close to truth. We actually placed an issue report for Magento 2 core team, and they didn't provide us with an explanation why it's disabled, but we were informed that it will get used in Magento 2 before it gets out, so fingers crossed. Now, viewfiles fallback. This is a new cache type introduced in Magento 2 because resolving assets in Magento 2. Asset is actually just a fancy term for mostly static resources like images, CSS, PHTML. So resolving paths to these files is a very resource-intensive operation, and on the other hand, it's very well cacheable. So in Magento 2, we have this new cache type to cache what actually? It actually caches resolved paths to required assets. Another new cache type, which is similar, viewfiles preprocessing, it's also an addition to Magento 2. The thing is, requesting CSS type of assets in Magento 2 is even more resource intensive, because if you follow Magento 2 development path, we now have some preprocessing. So before serving plain style sheets, Magento has to crunch Magento flavor tricks like Magento import. Also, inside the CSS style sheets, you can have these scope notation file references, and ultimately, if a file is written in less preprocessor has to be invoked. Okay, this is a complex operation, and it takes both time and resources. That's why we have a dedicated cache type, which stores paths to preprocessed assets. So in current Magento code, the only asset which is preprocessed are style sheets. And it works in a way that if Magento finds this path in its cache, it will assume this preprocessing has been done. Again, this depends on application modes. This is kind of more complex than Magento 1 in Magento 2. But again, in most cases, it provides a decent improvement performance-wise. Now, the most important change in current Magento 2 code is the introduction of PageCache module out the box. So it's the whole point is to have something similar to what you have in Magento Enterprise Edition, but it works much differently. First of all, it comes in two flavors. PHP-based, it's called built-in, and reverse proxy-based, Varnish. Now, built-in is the default, even though Varnish is not the default caching strategy in Magento 2. It's obvious from the source code that architecture is geared towards reverse proxy based caching strategy. I say that because regardless to which of these caching strategies you have enabled in Magento 2 admin, whether request gets cached or not depends on cache control HTTP header. So, for example, if Magento 2 wants some request to be cached, it'll send cache control public header. On the other hand, if some request has to be cached by browser, Magento will send cache control private HTTP header. And ultimately, if a request shouldn't be cached at all, Magento 2 will send no store, no cache control. So this is basically what Varnish and all the other reverse proxies are using as a basis for caching, this cache control header. Now, going up the abstraction ladder to a place where you as a Magento developer actually write Magento extensions, luckily you don't need to send these headers manually. That would be tiresome. For example, you have this block whose validity is very important, maybe to a point where you want to disable PageCache on this whole request. You can do so by using this cacheable equals false attribute. You can set it, for example, through layout. And this will actually instruct Magento 2 to send the cache control no cache header automatically. We're basically talking about mechanism for disabling PageCache on per handle basis. One example, we have checkout. There's no sense to have any kind of PageCache on checkout, and this is the mechanism current Magento 2 code uses for disabling PageCache on pages which are by concept not cacheable. Now, good old hole punching. In Magento 2, when we have the dynamic content and we need to punch a hole through caching, we have two scenarios. First scenario is to set isco private variable to some block, and this would instruct Magento to look at this block as a private block. So this block will not get cached. It will get served by through Ajax, and it will get populated by JavaScript. On the other hand, we have a situation where Varnish is enabled and the block has its own time to live set. In this case, and only in this case, edge side includes mechanism of Varnish will be used. I'll talk a little more about edge side includes. Basically, my first assumption was that when you activate Varnish in Magento 2, you will lose that whole JavaScript thing which replaces your dynamic blocks. This isn't the case, and if you think about it, it's actually logical because you have some information like, for example, number of items in cart or your name. These are dynamic blocks, but they are private. Why would my name be stored in any kind of cache except maybe in my browser? So even when you have Varnish enabled, ESI, a mechanism of Varnish for caching these dynamic blocks, will not get used always. Most of the blocks in Magento 2 code are currently delivered by Ajax. Actually, only one block is delivered through ESI. It's the catalog top navigation. It's that little bar where you have all the categories. It's dynamic content, but there's nothing private there. So it can be cached through Varnish. A few words about built-in caching strategy. As I previously mentioned, it's the default in Magento 2, and it works much the same way as Enterprise, Magento Enterprise full page cache does, in the sense that cache is stored by PHP code. Every request reaches Magento, and Magento is the one who decides whether it'll serve this request from cache or it'll save cache by PHP after request has been executed. Now, dynamic blocks with built-in caching strategy, they are not cached, as I previously mentioned, because the only mechanism if you use built-in caching strategy is to have these blocks fetched through Ajax and JavaScript to populate content of these blocks. Mechanism through which this is accomplished is that Magento 2 outputs placeholders like the one you see here. This is probably familiar to anyone working with Magento Enterprise Edition because its full page cache has these kind of placeholders which get replaced. The only difference is that in Magento 2, JavaScript is the one who does the replacement, not PHP like in Magento Enterprise Edition. Let's look at the pros and cons. The fact that built-in caching strategy is the default and that it works out the box with no special setup is definitely a good pro. On the other hand, built-in caching strategy leaves a lot to be desired when it comes to performance. Why is that? It's because when you use built-in caching strategy, every request reaches Magento and it triggers partial initialization of Magento in order to possibly extract data from full page cache storage. And this takes both time and server resources. That's why performance of built-in caching strategy, it's okay, but it could be better. Okay, second and most promising caching strategy in Magento 2 is reverse proxy based. Varnish, you probably heard about it. On every conference, you have at least one Varnish related talk. I'll say a few basic words. Okay, Varnish is a dedicated caching server standing between Magento on the right side here and between store customers. And it serves cached content wherever possible. So the performance way Magento Varnish improves performance is by avoiding requests reaching Magento in the first place if Varnish is able to serve cache data. Now, enabling Varnish in Magento 2 configuration, you simply delegate maintaining and serving of cache data from Magento to reverse proxy. So Magento cache storage, when you have Varnish activated, does nothing. PHP does not save any content. Everything regarding caching is done by Varnish. To recap, if a block doesn't have time to live set, you set this actually through layout in Magento 2. Block without time to live set is a dynamic block, and it will not get cached. It will be considered as private, and the browser is the one who will take charge of caching this request if browser decides to, but nothing gets cached in Varnish. On the other hand, with time to live set, dynamic blocks are cached through edge side includes mechanism of Varnish. Here you can see a placeholder for edge side includes mechanism. So Magento 2 outputs placeholders for all blocks which have time to live set. Placeholders look like this one, and Varnish then replaces these placeholders by real content just before it serves requests to whom this placeholder belongs to. So basically Varnish does contact Magento when necessary, and once it contacts Magento, it stores content for this block represented by this placeholder in its own cache. So you get the situation where a Varnish holds both page markup and all the dynamic data on the page, and it's able to return result to customer without even contacting Magento. That's actually the best situation when you have a full cache hit. Pros and cons of Varnish. Varnish is the best possible caching solution, assuming we can configure it properly. On the other hand, Varnish is very difficult to configure. I've been there, done that. It takes a lot of time. You need a dedicated admin personnel to assist you. It's not something a developer can do in an hour or two. And additionally, if you do not configure Varnish properly, you can achieve even worse results than with built-in caching strategy. So it's not plug and play. Not plug and play. Definitely, you need to work a lot to get it configured correctly. Additionally, You probably noticed that Google promotes having a store-wide secure sockets layer encryption, so that you have an entire store on HTTPS. This actually affects your ranking in the last few months, if I'm not mistaken. Unfortunately, Varnish in its current versions is not able to decrypt HTTPS traffic. So if you want to have HTTPS on a store which is behind Varnish, you need to configure additional proxy. It's usually called a secure sockets layer termination proxy, which would then decrypt this traffic and tunnel it through unprotected, unencrypted ports to Varnish. This only magnifies the whole experience that Varnish is hard configure, because now you cannot have a Magento store without HTTPS on at least checkout. Now to conclude, we have some benchmarks. I must first point out that even though we used official performance toolkits for both platforms, both Magento Enterprise Edition and Magento 2, hardware we used was seriously underpowered. When I say seriously underpowered, this was executed on my laptop. Additionally, Magento 2 is alpha. Comparing it to Magento Enterprise Edition definitely doesn't do it justice. Therefore, these charts shouldn't be taken seriously. With that being said, here you can see that even with Varnish configured, in my tests, Magento 2 was roughly 2 times slower than a Magento Enterprise Edition. At least if we look at average response times of both backend and front-end tests. These tests in official performance toolkit, this is actually a great tool, but it's even too realistic. Most tests for Magento test, I don't know, catalog category, product view page, and these kind of things. But with Magento Performance Toolkit, you have this scripts which actually are able to log into Magento admin and do store search and things like that. That's probably what affected these charts to be to appear a little slower than you would expect only on front end, even though Varnish is configured, because Varnish is not used in Magento admin. So if these charts are at all relevant, I pointed out why they shouldn't be taken seriously. But if they are at all relevant, I cannot say I'm impressed with what Magento has to offer at this time when it comes to performance. And this is okay. It's to be expected because it's an alpha software. And let's hope that Magento 2 team will spend more time on performance as the general availability of Magento 2 approaches. Actually, I had comments from Ben Marks mentioned it, and Alan Storm mentioned it, that performance didn't have a lot of attention so far. So let's hope in the next year or so we will at least bring these charts closer, if not achieve that Magento 2 is even faster, even though we know that dependency injection and this new stuff introduced in Magento 2 is quite heavy on the resources. So again, fingers crossed. Now, are there any questions? Anyone? Okay.
Do you know, if at all, how Magento 2 communicates ESIs to Varnish? Is there some kind of a dynamic VCL application like Turpentine, or is it all static?
You mentioned ESIs. Yeah. So the ESIs are actually outputted along with page markup, and Varnish, when it encounters ESI placeholder, it looks in its own cache storage. If it doesn't find anything, it has Magento configured on some other port, and it pings Magento, and it gets the data it requires. Hope this answers your question. Anyone else? Magento 2, Varnish, usually interesting topics. Okay, guys, thank you very much. My Twitter name. If you have any additional questions, you can contact me by Twitter, and I'll do my best to assist you. Again, thank you.